Alrighty, welcome everyone. So today we're going to be having a look at compound interest back in the traditional sense. So the last few lessons we've been looking at using these formulas that allow us to predict one future value ahead. But that's not the way we've done it for the last 2 years. So today we're really going to be going back through that and really having a look at our old way of doing it, which looked like this. A equal P 1 plus I to the power of n. So this is a quick reminder. A is our amount in the account. It's our future value. P is our starting value. That's a 1 in the formula. It's always just a 1. 1 plus I. Our I is our interest rate as a decimal. And our n is our number of compounding periods. So if we just start off with a more straightforward example, we could think of something like this. Alrighty. We're going to start with $4,000. We're going to invest it for 6 years at an interest rate of 8% per annum, compounded yearly. Okay, so this is just a real straightforward example of something that we might look at. So what does that mean? Well, it means that we've got all of our variables set up, ready to go. We've got our P, we've got our N, and we've got our little I. All ready to go, no stress at all. So let's just go through it. A is equal to, 4,000, 0.08. Alrighty. Now we have a choice at this point. We either go and type it into the calculator and work it out straight away, or you can do it in a few steps. I'm just going to type it straight in the calculator. The only thing is you do have to be careful. So you want it to look exactly like it should in the book, otherwise mistakes will get made. So that's what it looks like in my calculator. And there's my final answer. So $6,347, and if I round it up, 50 cents. And so, if I invested $4,000 for 6 years at 8% compounded yearly, I would make that much money. So, my example that I want you to have a go at is I'm going to make it $4,000. 7 years, we'll say 6% per annum, compounded yearly. Alrighty, so have a go at that one in your book. Pause the video, have a go. Alrighty, so once again, let's go through, label our variables. P, N, I in this case. And we've got that it's compounding yearly, which means it's going to be nice and straightforward to do. So, formula A equals P. Substitute in. Calculator. So all I've done is I've taken my basic formula, substituted in the values that I needed to, and now I have got something that I can type directly into the calculator like so. Push equals. Make sure we get the same thing. So 6,014.52. You can see that even by changing these numbers a little bit, change the percentage by 2 and changing the years by 1, that we get quite a different amount of money saved in the end. We still save about $2,000. We still get that much interest, but it's changed by about $300 in between the two different ones that we've just had a look at. Alrighty, well these are both the same. Alrighty, so these are both the same in the sense that they are both compounding yearly. So the money, is the same. The years are very similar. The percentage is pretty similar. but they're both compounding yearly, and that's really the big similarity, because when it's not compounded yearly, a big part of the calculations do change, and it does make the question a lot more complicated. Alrighty, so now we're going to start having a look at what does it look like when we are moving to different compounding periods. So let's have a look. So I'm actually going to leave everything else the same for the minute, and the only thing that I'm going to change is the compounding period. So it's still going to be $4,000. It's still going to be, 8% per annum, and 6 years. But this time, not compounded yearly. I'll say compounded quarterly. So now I don't really care about what the percentage per annum is. I want to know what the percentage per quarter is. So my I value is going to be affected by it. Alrighty, so my interest rate has been affected by the fact that it's quarterly. I don't want a yearly, I don't want a per annum, I want a quarterly one. So if my interest is currently 8% per annum, I want it to be quarterly. Which means I'm going to divide it by 4. So now my interest is 2% per quarter. But the other thing is now it's going to be compounding more often, not just 6 times. It's going to happen 4 times every single year. So that means my N, which was 6 years, I don't want it in years anymore. I want it in how many quarters that time is. So I want this to be in quarters. So I'm going to times by 4 here. So my 6 years is going to become 24 quarters. And that's my value of N. Alrighty, so I've done the 2 necessary conversions. My P is still good, still just hanging up at the top. I've used the quarterly fact here and here. So now I'm good to just jump straight into the calculation. So A is equal to and now we're up to the calculator section. Pop it in. And we get 6,433 and 75 cents just by rounding it there. Alrighty, so now I want you to have a go at this one instead. It's going to be very similar, $4,000, 8% per annum, 6 years. But this time I want you to, instead of compounding it quarterly, let's do compounded, I'm not going to do monthly, let's do half yearly, so it means twice a year. Alrighty, so pause the video now, have a go through that one, see if you can get it. Alrighty, so my interest rate of 8% isn't a yearly percentage, and I don't want yearly, I want half yearly. So to make it from per annum to half yearly, got to divide by 2. So it's going to give me 4%. But my number of compounding periods has got the reverse problem. It's currently in years, but I need it to be in half years. So that's going to give me 12 half years. And now I can substitute into the formula. So my A is going to be P 1 plus I to the power of N, 4,000, 1 plus 0.04. Make sure you convert it into a percentage, from percentage to a decimal to the power of 12. And now it's just a calculator problem. you should have gotten $6,404.13, rounding to 2 decimal places, because it is a dollar amount, so we're always going to be rounding to there. Now, one thing you might notice that your answer is very close to my answer, but it's not exactly the same, which means that by changing the period, like what we're doing here, quarterly versus half yearly, or even if we go back to the yearly, each of these values is subtly different. And that's something we're going to be having a look at later on. But my aim for today is that if you can calculate compound interest using the formula for both the yearly case and for other cases like quarterly or half yearly or even monthly and daily, then you're all good. Hope you had a good time, and I'll see you next time.